Okay, so this is a quick introductory video to demonstrate how it's relatively simple to get up and running to conduct hierarchical Bayesian estimation on your delay discounting data. So the first thing that you'll need to do is to go to the GitHub repository here. You're after delay discounting analysis, and you'll download it to your machine. Now, here it is installed on my laptop, and we have a couple of folders here. The key one of interest is demo. DD Toolbox is the core MATLAB code which actually conducts the analysis, but you only need to know about this if you're going in to tweak things. For the moment, we're going to focus on a demo folder. So we have a script here. Now this is outlined on the website, and the script outlines the basic steps that you need to follow in order to conduct an analysis. What I've done in this script file is to add a whole bunch of comments in order to make sure it's very clear what is going on. But for the moment, in order to clarify the fact that the steps are actually quite simple, I've got this reduced minimum working example here. First of all, just to say that in our demo folder, we have a folder of data, and this is what we're going to analyze. So each of these files corresponds to a participant. So if we go and have a look, we can see the structure of the data. So each row is an experimental trial. So each column represents a different important thing. So A and B are the values of the immediate and delayed rewards. The columns DA and DB represent the delays of those rewards. So the delay for the first reward is 0, meaning that it's immediate. Whereas in this trial, for example, the delayed reward was £85 or dollars, and this was to be received in 157 days. This last column here, labelled R, is the participant's response of whether they chose the immediate or delayed. And we have a couple of different participants worth of data here. This is what we're going to analyse. So let's have a look at the core steps that happen. Firstly, very simply, we just need to make sure that MATLAB is sitting in the relevant folder. This is the demo folder. Then we need to make sure that we have a path to the toolbox. So this just is a pretty simple thing. Then what we're doing is we're going to create a data object. So this is the line which creates a data object. And then we ask the data object to load up all of the participant data files. Now we define a MATLAB cell array of participant file names here, and I've done it this way as opposed to choosing a more user-friendly graphical user interface, because this way is more reproducible. There is a script which I can save, and I know exactly which participants I've analysed. So this is, in one sense, a bit frustrating to have to write these down, but it's also good for reproducibility. In these lines, what we're going to do is create a model object, and we're telling the model object where the toolbox is, that we want to do our MCMC sampling with JAGs, and that we want to conduct that on the data object that we just created. We're then going to set a couple of parameters to do with our MCMC sampling. So right now we're going to choose 10 to the 5 total samples, and that's going to be computed over 2 chains. I'm running this on a laptop with 2 cores, and I have the parallel computing toolbox from MATLAB installed, and so it will run these 2 MCMC chains in parallel, which is quite nice. Then finally we're going to get the model object to conduct inference. When we come to do this, I will pause the video because this can take a few minutes. Finally, we end up asking the model object to export some parameter estimates and to plot a bunch of outputs. So we're going to run this, and I'll pause things shortly because it will take a while. You can go and get yourself a cup of tea and we'll come back for the results. Okay, so the MCMC sampling is now complete. We've come back from our cup of tea and we discover a whole range of outputs have been printed to the command window. These are also generally saved as text files into our project folder, and we also have many graphical outputs. So first of all, we get some univariate summary statistics. So these are saved into a text file which you can import into SPSS or JAGS or whatever you like to analyze things with. And we also get a MCMC chain convergence report. So what we want to make sure is that the analysis that we've just run is reliable and that the MCMC chains have converged. So we have the R-hat statistics printed to the screen, but then also outputted to a text file. So we can go and double check these, that the convergence isn't too high, that the R-hat statistic isn't too high. If it is, it's flagged, but in this case we can see that we have no convergence issues, and so we get a little smiley face at the end. We also get a table of parameters here. So we have various parameters, the M, C, alpha, and so on. These are outlined in the paper. Each row is a participant. We also have the group level inference. And for each parameter, we have the mode, but we also have the 95% credible intervals. So this is, like I say, saved to a text file. Now, we also have a bunch of graphical outputs, the meaning of which will be clear from reading the paper. This is very useful for getting an idea of what your data is like, getting a quick insight, and I think these plots are quite nice. They look nice in a paper. So you can go through, have a look at how each of your participants are responding. This is the group level inference. Okay, so hopefully that is a quick summary showing that it's very doable, very quick and easy to get an analysis workflow set up. If you're watching this video some time from now, there could be some slight changes in how you run the code and the type of outputs you get. And this is because I'm trying to upgrade the code, trying to add a few new features, make it even easier to use. But hopefully this gives you a good idea that it's all very doable. Enjoy.